Now moving on to example 4, this example deals with repaying a car loan, something else that we all will have to do at some point in time. It says, suppose you buy a used car and agree to pay it off over 1 year. The bank calculates your payments as $229.19 a month at an interest rate of 10.5% per year, compounded monthly. What's the actual cost if you were to pay cash for the car today? Now, in this case, then, it's actually the present value that we're solving for. So the question is saying, if you weren't going to take a loan under those conditions, but instead you were going to pay for the car up front, what would it cost you? So we could use the information that's given to figure that out. So the N value that we would use would be 12, since we're going to pay it off over 1 year. The interest rate is 10.5. Our payments are negative $229.19. The future value, since this is a loan, remember, would be 0. We are making monthly payments, and the interest is compounded monthly. And so, if we cursor up to present value and press alpha enter, we'll get a present value of just basically $2,600. $2,600.04, I think it is. So in other words, to buy the car today would cost you about $2,600. Now it says, how much interest will you pay if you choose the payment plan? Well, if you choose the payment plan, your total payments would be $229.19 a month times 12, which I believe comes out to $2,750.28. And we just figured out that if you were to buy the car right away, it would cost you $2,600.04. So if we find the difference between the amount you would pay using the payments and the amount you would pay in a lump sum, that would tell us what the interest was. So the interest is $150.24. So not very much, really, since you're only borrowing the money for 1 year. And in many cases, we do need to use loans to buy things like cars because we don't always have that kind of money just laying around waiting to make a major purchase. Okay, on to example 5. It says, determine the weekly deposit needed to save $3,000 in 3 years if interest is earned at 2.5% compounded daily. All right, N is the number of payments. So we're making weekly deposits for 3 years. So beside N, we could type in 52 for a weekly, 52 weeks a year, times 3. The interest rate is 2.5. The present value, since this is an investment, is 0. Payment is what we're calculating. Your future value will be $3,000 because that's what we're trying to save. Now, the payments per year would be 52 because it's weekly, but it's compounded daily. So our compounding periods per year would be 365. So cursor up to payment, press alpha enter, and we get a weekly payment of $18.52 that we would need to save. Now you've noticed when we're figuring out our values for N and the payments per year and the compounding periods per year, it's helpful to have a quick reference for those of you who sometimes forget how many months are in a year. Well, I guess you don't forget how many months are in a year, but weeks. Sometimes we forget our days, and sometimes interest is compounded semi-annually as well. So let's fill in this chart so that you can refer to it if you forget, okay, how many times per year each scenario would be. So annually means 1 time per year, and this would apply to your payment schedule as well as your compounding periods for your interest, okay. Semi-annually would be twice a year. Quarterly is 4 times per year. Monthly is obviously 12. Weekly is 52. And daily is 365. Okay, and that concludes this lesson.